Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is Oracle Intro to Cloud Operations, where we will cover the fundamentals of operations in Oracle Cloud and some of the tools available. I'd like to introduce Winnie and Uma as the main presenters. And with that, I will hand it over to Uma.
And welcome everyone to our Day One and Beyond session on cloud operations. My name is Uma Kumar. I am a cloud engineer on OCI's customer enablement and personal training team. Today I am joined by Winnie as well, who's going to help me deliver the session. Winnie, if you want to introduce yourself.
Hi everyone, my name is Winnie and I'll be going through the second half of today's session. And yeah, happy to be here.
Awesome. Okay, so just to talk about a brief agenda of what we're going to be covering today. This, as you know, is the operations, introduction to operations session. So we're going to start off by understanding what we mean by operations. That term itself is pretty vague and can encompass a variety of different tasks when using a cloud provider, like security, governance, monitoring, maintenance, provisioning. So we're going to kind of simplify it down and describe it in 6 different terms that we believe will encompass operation activities. And then from there, we're going to start off with how you can just access OCI in a variety of different ways. You guys might be familiar with our graphical interface, our OCI console, but you can also utilize OCI REST APIs, infrastructure as code tools, all to be able to access your resources and provision them on OCI. So then we'll kind of go into our IAC discussion, discussing how to utilize tools like Terraform and Ansible on OCI and the recommended best practices. And then in the later half of the session, Winnie's going to introduce our observability and management platform, which is to gain insights into telemetry for your applications and workloads in OCI. And from there, she will go into our monitoring, notifications, events, functions, and logging service. So a brief objectives that we want you guys to be comfortable with by the end of this session. Number one, explain the core areas and principles of operations in OCI. That's just how I'm going to be choosing to define it today, as well as understand the different tools available to achieve these different operational activities, such as deploying and managing your resources. We also want you to be able to define and understand different use cases for the different operational tools, mainly observability and management, understanding when to use monitoring with notifications, events with notifications, and kind of their overall value as from a management perspective. And then lastly, I'm going to be spending quite a bit of time in Resource Manager today and showing you a demo on that. So we want you to be comfortable with our Resource Manager tool, understand what it is for, and be able to comfortably create a stack in the OCI console. Right, and then without further ado, I'll go ahead and get started into our what is cloud operations. Before I do that, I want to kind of breeze through a couple of slides just describing our overall cloud ecosystem as well as our shared responsibility split, which is what this slide is describing. It's just the split of responsibility between the customer, which will be you guys on the call, and our cloud service provider, which is OCI or Oracle. Today, we're mainly looking at infrastructure as a service, so that second column. And I also wanted to show Oracle's complete cloud ecosystem. So right now, wherever you are in your cloud journey for your company, you may have some of the kind of concepts that you see here. You may be running Oracle applications using some of the infrastructure components that we have on here. This is really just showing you kind of the total landscape that a customer could have. Today, I want to point out that we're really mainly focusing on our core IaaS infrastructure, like compute, storage, and networking, kind of talking about how you can deploy all of that through infrastructure as code and automate your operations that way. And then we'll also, like we mentioned before, be discussing the observability and management platform suite of tools, which is at the bottom there. And then we did also want to point out at the very bottom, you'll see the different types of deployment options, our commercial and government cloud regions, as well as choosing a hybrid cloud. In today's day and age, we understand that our customers are not solely using one cloud, they're using a mix of multiple clouds as well as maybe their own on-premises data center environments too. All right, so now I'm going to go into how I'm going to define cloud operations today. So these are the 6 kind of verbs that we've chosen that would encompass a lot of operational tasks that you may have once you're deploying and developing on OCI. So on the left, we have building and configuring your environment. This is a very important task that you're going to want to do, obviously, when you're building out applications, standing up your workloads. You need to make sure that you are building and configuring in a way that is reliable and efficient. So obviously, there's several different ways to go about that, and that's why we're going to talk about the different ways to access OCI and do that. One of the recommended ways is obviously going through infrastructure as code. So in that way, you can automatically and reliably deploy your infrastructure in OCI. There's several ways to do this. There's several different tools at your disposal. Today, we're mainly going to be discussing Terraform and Ansible. Along with Terraform, OCI also has a wrapper tool for that software called Resource Manager, which is what we'll be delving into later on. And then once you've, built out and configured your servers, your environment, obviously you need to make sure that you are monitoring your workloads, detecting any sort of anomalies, and making sure that you are responding to events swiftly and as automatically kind of as possible. So that's why under Monitor and Protect, we have a few of our observability and management platform tools, like our OCI monitoring service, our event service, and our function service. Under Secure, we have our audit log. So we'll talk about the different types of logs you can choose to have in your logging service to search through and view. Audit is a great way to kind of see the trail of any sort of API call or action that was made within your entire tenancy. It's a really good investigative tool to kind of figure out what happened and when, if you are detecting any sort of like drift or change in your application or workloads. And then lastly, we have governance. This really is something that is going to be throughout all of these different steps that I just described. It's one of the first things that you're going to be doing in your tenancy is making sure that you are setting up your identity and access management instance. You're making sure that you have the proper users provisioned as well as you're placing them in groups. And you've created several policies basically allowing these groups to have access to resources in your different compartments. So none of this is really possible, what I described, without having this governance piece in place first. All right. So now we're going to start off with the discussion of, when you're building and configuring an OCI, obviously there's several ways to do this. So I first want to introduce the different ways just to access your resources and build within OCI. So the first option you have is our Oracle Cloud Infrastructure Console that you guys may be familiar with if you have some experience with OCI already. The console is going to be an intuitive graphical interface that lets you create and manage instances, cloud networks, and storage volumes, as well as that's where you can manage your users and permissions. We also have our Oracle Cloud APIs, which are our typical REST APIs that use HTTPS requests and responses to access several different services on OCI. And you can use these APIs in conjunctions with our software development kits that are available for easy integration with our OCI services, including different SDKs for Java, Ruby, and Python, and more. We also have a command line interface or CLI that's going to provide you with the same kind of core functionality of the console, but you can also run some additional commands, do some additional features that you may not have access to do in that graphical interface in the console. Next is Terraform. That is an infrastructure as code software that will allow you to define infrastructure resources and files that can persist, version, and share. Going along with that is Resource Manager, which I mentioned provides kind of a Terraform as a service on OCI. It's going to help you to install, configure, and manage resources using that infrastructure as code model. And then lastly, we also have Ansible. That's another IAC tool. It is a procedural and imperative language in which it allows you to automate, configure, and provision cloud infrastructure. You can deploy and update software assets, as well as orchestrate more complex operational processes. All right, So starting off, I'm going to kind of dive deeper into all of the different ways to access OCI that we just discussed on the last slide. And I'm going to start off with the command line interface. Again, that is a tool that you can use on your own or with the console to complete different tasks on OCI. You can run some additional features like we mentioned, such as the ability to run scripts and additional commands. And the command line interface is going to be built on Python software development kit, so it can run on Mac, Linux, or Windows. And how it's working is the Python code is making calls to our OCI APIs to provide functionality implemented for your various services. So the CLI is really useful for more managerial tasks like finding and locating resources. You can audit your tenancy also by using query commands. You can build out scripts as well, script with the command line to perform specific functions like managing your compute instances, maybe programmatically turning on and off particular environments. And you can help execute these scripts also to help you kind of build out your infrastructure. It is a bit clunkier. It's not as maybe easy or intuitive as doing it with a pre-baked software like Terraform and Pulumi, but you can, launch instances and things like that from the command line. The CLI is also flexible and scalable in where and who uses it. You can access it in a variety of different ways, some of which could be the console, developer image, or PowerShell. Next, we have our Oracle Cloud REST API. So this is what, again, is going to be called when using the Python SDK for the CLI. It can be used through a variety of different software development kits to manage a large variety of tasks on OCI. Permissions for these API calls are always going to be applied by the user, and the CLI access is going to be rule defined in your config file. So overall, making a lot of the tasks using REST APIs would be completed kind of more easily and just have a better overall deployment utilizing the command line. Next, I want to talk about software development kits. So a software development kit in general is just a set of software tools and programs provided by different hardware and software vendors that developers can use to build out applications for specific platforms. Each SDK will provide you with tools you need to develop an application, like code samples, documentation to create, test, and troubleshoot. So with our OCI SDKs, you can build and deploy apps integrating with our OCI services. In addition, if you want to contribute to the development of these SDKs, they are all open source and available on GitHub. And again, utilizing SDK is just another way. You can script out different things, build out your infrastructure, automate different tasks as well. And when you're scripting with the SDKs in the command line, these are all just abstractions of the OCI REST APIs. Which again, this could all be another method of building out your infrastructure without using a specific IAC tool like Terraform, Pulumi, or Ansible. And then I also want to introduce Cloud Shell. Cloud Shell is a free web browser-based terminal accessible from the Oracle Cloud Console that is pre-installed with a set of useful tools. Each user is provided 5 GB home directory, which will be persistent storage for your files, and it's going to run under the same permissions as your console access. So this is kind of a great tool that I'll show you where to access it and launch it in OCI. All right. Now we're going to move deeper into our infrastructure as code discussion. I'm going to introduce Terraform and Resource Manager and Ansible, and then we'll do a demo in the console. So with infrastructure as code, essentially, especially with a tool like Terraform, where it is a declarative software, you are going to define what you want the resulting infrastructure to look like. So with Terraform, it has the intelligence built in to produce the end state for you. So essentially, you're just defining everything up front. You can either use HCL, HashiCorp config language, or JSON, and your infrastructure is always going to be documented before you're even deploying or provisioning it. So the ultimate best practice that I want to highlight with infrastructure as code is to always make changes through infrastructure as code. So you never want to deploy infrastructure with a tool like Terraform and then go into the console or the command line and make some manual changes. If you're following best practices, your architecture definition is always updated and documented before it is applied. You can leverage different reusable modules and proven configurations with Terraform to help you kind of accelerate the delivery of a complete application architecture. And because the configuration is going to be validated and tested, it can be deployed by anyone, using it in a CD pipeline, an automated bot. You're getting consistent results each time. So now going into what Resource Manager is. Resource Manager is a fully managed service that's going to let you provision and manage infrastructure resources using Terraform. So you can bring in your Terraform template definitions and easily create and manage your infrastructure resources. This allows you to use infrastructure as code to automate provisioning across all OCI resources like compute, networking, storage, and much more. Resource Manager also does have support for command line, SDK, and the console. And essentially, it's going to help you mitigate a lot of problems that users face when they are deploying resources on any cloud. Another benefit is you can kind of repeat deployments or execute it however many times you want. So if you want to create multiple environments, let's say for a DR scenario, that's very easy to do with a tool like Resource Manager. Another great benefit of Resource Manager is that it's going to save the state securely for you on object storage and will also lock if multiple members of your team are trying to modify it. So it prevents a lot of possible corruption and inconsistencies. And because it is cloud native to OCI, it integrates very well with our overall OCI platform, like identity and access management, tagging, and key management service as well. Some terminology just to be familiar with when you are using Resource Manager. Number one is your stack. So that's just going to represent a set of OCI resources that you create in your tenancy. So each stack will always map to Terraform configuration files and a state file. Then you have jobs that will perform actions that are defined in your configuration, and the possible actions are the normal Terraform actions like plan, apply, destroy, and you can also import state. So how does this all work together? How does Resource Manager orchestrate infrastructure provisioning? Well, first, there's a few different ways you can get started in Resource Manager. You first will start by authoring your own Terraform configuration files that describe your infrastructure. You can also start with using some sample templates, which I'll show you how to do in the console, or you can also import existing infrastructure with a single click. So all different ways to create a stack. Once your stack is created, then you can run a plan job. So when you run a plan job against the stack, the plan job will parse your configuration and create an execution plan, but it's not actually going to take any action on the stack. And then once the plan job is completed, you can look at the execution plan by viewing the job's log entries in Resource Manager and just confirm that, okay, it's going to perform all the expected operations that you want and in the proper sequence. And if you're satisfied with that execution plan, then now you're ready to do the work of actually provisioning the stack with the resources that you defined. And that's what the apply job does. It's going to take that execution plan and will actually apply it to the stack, and the result will be a fully provisioned stack. So I mentioned that Terraform will keep track of your state. So your state file essentially is going to be a JSON file that is going to maintain a lot of important information about the state of your resource configuration. So it's going to map your stack's resources to your configuration and will maintain essential configurations like resource dependencies. So something that's great about Resource Manager is that it does generate and update state files automatically. And it does support job locking by default. So only one job at a time can run on a given stack. One thing that I wanted to point out is the difference between utilizing Terraform just with the open source OCI provider versus with Resource Manager. On the left-hand side, you'll see we have our provider.tf file in which we have our provider block, and we are providing the tenancy OCID, user OCID, a ton of variables essentially to authenticate us as a user in OCI. With Resource Manager, since it's already native within the console, you're already kind of logged in and authenticated. You really just have to provide the region and compartment OCID. You don't have to provide that whole provider block. Everything else in your stack will stay the same. So all the same configuration, all the same JSON and HCL will be the exact same besides this section. All right, I'm gonna do a brief overview of Ansible and then we'll take it to the console. So with Ansible, what is Ansible? Ansible is an open source software providing provisioning and configuration management features. It can configure systems, deploy software, orchestrate advanced workloads to support application deployments, system updates, things like that. Kind of why would you use it? What's the nice thing about Ansible? It's pretty easy to set up with a minimal learning curve, and you can manage remote systems very quickly and in parallel. It's also all agentless, so it just leverages SSH. And essentially, like I think I mentioned this before, it is an imperative or procedural tool. So instead of describing your end state, you are using YAML essentially to create playbooks, specifying your tasks essentially and step by step what you want the software to do for your provisioning or configuration. So what are some things that it can do? There are 4 key use cases that I kind of want to talk about. First one is continuous delivery. So in continuous delivery, we have stage and test. So let's say you have your Ansible inventory, you can actually split that and separate your environment into different groups of have a test environment where your plays are running against a staging machine. And if that test passes, then you can instantly run them against production if you so choose to do. Ansible can also work with like networks, load balancers, and monitoring systems that may need attention during a certain like a rolling update, for example. So like you can add or remove servers from your load balancing pool and disable monitoring alerts for each machine that's going to be updated. There's also orchestration as a use case. So let's say you're managing clustered applications and multiple data centers, public, private, hybrid clouds with more complex dependencies. So you can orchestrate your complex tasks with Ansible. So basically just making sure that all the tasks happen in the proper order that you specify, like the database is up before the backend server is up, or maybe having your front end server removed from the load balancing pool before it's upgraded. Another use case is application deployment. So Ansible gives you the ability to deploy multi-tier applications consistently from one common framework. So rather than writing custom code to automate your systems, you're just writing simple task descriptions. And you can do things like configure key services, as well as push application files from one common system. The last use case is security automation. So you can do some threat hunting. So things like automatically tuning the level of logging. You can create new intrusion detection system or IDS rules and new firewall policies, facilitating the detection of more threats. You can also do some incident response. So things like remediating faster automating actions like blocking attacking IP addresses or domains, maybe accepting non-threatening traffic or isolating suspicious workloads for further investigation. Those are all kind of security automation use cases that you can achieve with Ansible. So when we talk about OCI with Ansible, Oracle provides a number of Ansible modules that you can install to interact with OCI. Ansible works by connecting your nodes and pushing out small programs called Ansible modules to them. And the Oracle provided Ansible modules will give you the opportunity to provision and configure your OCI resources on an automated basis. To use these OCI modules, you want to make sure that you have prerequisites set on your control node, which is the computer from which the Ansible playbooks will be executed. If you run Ansible in your own terminal, you also want to make sure that the OCI Python SDK is installed. That's what's going to enable you to write code to manage your OCI resources. And you can also use Ansible in Cloud Shell since it's already set up there. So this is my cloud homepage. And to access Resource Manager, it's going to be, you'll first click the navigation menu on the top left screen and go down to Developer Services. Under Developer Services, Resource Manager has its own page. So I highly recommend if you are unfamiliar with Resource Manager to take a tour to kind of understand the different aspects of Resource Manager. There's also a lot of quick links to get you started with just creating a stack, as well as some quick starts. So these are just some Oracle provided templates that you can use to start provisioning some architectures. We have links to some tutorials down here, as well as links to further documentation, as well as anything with what is new with Terraform, or sorry, with Resource Manager. So down here is where you'd be able to create your stack. So I'm going to take you through the stack creation process. So there are 4 main ways to create your stack, and I went through a little bit of them in the slide deck. Number one is just uploading your configuration files. So let's say you have a folder on your laptop with all your configuration files. Maybe you want to drop them into an object storage bucket first and pull from there, or you can just zip them up and drop in your zip file. So that's if you have authored, your own configuration that you work with personally. You can also start out with a template and then make edits to the code as well and to your stack. So these are the different Oracle provided templates. We have several for different categories, like different quick starts, which are incorporating different types of technology solutions. We have service specific templates. These are for different services within OCI, like our AI services, networking, data science, compute. We have architecture specific templates, so these will be different landing zones or different quick starts that you can get started with. You can also create private templates as well. That would be in a different section of Resource Manager where you would create a private template, and then from here you could choose it to get started. You could also choose a source code control system. So if you're using like GitHub, our DevOps code repository, Bitbucket, you can do that to, you can choose that essentially to pull in your Terraform code. So either you'd want to create a source provider already, which I have one here, or you can just create it right when you're creating the stack. When you're creating a source provider, you want to give it a name, choose the type of endpoint, and then the type of configuration control system. So GitHub, GitLab, and then the server URL, or like a personal access token or something like that. And then you can create. Once you've created it, you'd be able to select the source provider. And then my personal access token has expired, so it's not letting me list my repositories. But once I update that and validate it, I should see a drop down of my repos and the branch that I want to choose from to pull. The last option you can do is existing compartment. So this is going to be for, let's say you have already started, creating different resources, provisioning services in OCI, but you're doing it all manually or you're doing it through the command line. And now you just want to capture everything in Terraform code and start using Terraform from now on, since that is the best practice. So you can do that by choosing this option. It's going to perform resource discovery. Essentially, you're just going to choose a compartment and region, and then you'll either select all services in that tenancy, or if you just want it to capture like a couple services, like maybe core for compute instances, maybe my database, those are just the services I want to capture. I can choose that, and then I'll go ahead and configure the rest of my stack, like give it a name, choose the compartment. I don't have any variables that I need to update since I'm doing resource discovery. And then I can review the information. Essentially what it's going to do, it's going to look through that compartment. It's going to capture all of my compute instances and database that I have, and it's going to create a stack for me. Once that stack is created, I can go in and actually view the Terraform files that it generates. So we'll generate that code for you. All right, I'm going to go into a stack that's already created just using a sample template. This one is for a compute instance. I just want to show you kind of the different options you have here. You can edit the stack again here. So the configuration source, the name, any variables that you need to configure, you can edit them here as well. Or you can choose to edit the actual configuration and code right in Code Editor. So this is a developer tool that you can access up here along with Cloud Shell. Cloud Shell is that terminal access, and Code Editor gives you an IDE. So it looks very similar to Visual Studio Code, and basically you can look through the Resource Manager plugin, locate the stack from your compartment that you're working in, and then be able to edit, see the Terraform files, and make any changes or adjustments. It takes a second to load, but I should have it here. So this is our Oracle plugin. These are the different services you can use Code Editor with for this plugin. So we're working with Resource Manager, and you'll see I already have my infrastructure compartment pulled up, and then this is the stack that I'm interested in. So I can go ahead and see these are my Terraform files. I can make changes that I need to, and then I can choose to save these changes or save these changes and automatically run a plan or apply action. I can also just download the configuration if I would like to, use my own environment to edit the code if I didn't want to do it like on the browser here. And then these are the different jobs I can run, my plan, apply, and destroy job. I can also import the state, download the most recent state file, and run a drift detection report. In the jobs, you can see all the different jobs you've run on the stack, some plan jobs, apply jobs, and destroy jobs. You'll see after an apply or a destroy job, you can view the state file directly. So if I click view state, it's going to bring me to the job details page. And down here under resources, you'll see this is the state file. So this is that JSON file that is mapping our configuration to our resources. Under the log file is where you can see some information, like Terraform being successfully initialized. You'll see it going through and creating the different resources from our execution plan. And then you'll see the apply was complete, what resources were added, changed, or destroyed. You can also download the Terraform configuration and Terraform state directly from here as well. The last thing I want to show you guys is drift detection. So drift detection report essentially is going to look at your current state of resources as well as your configuration, and it's going to tell you if any changes were made. So I can either run a drift detection report again right now, or I can show you the latest one, which we ran yesterday. So this is what it looks like. You'll see that it is in sync. If there were any changes, it would tell you modified. And you can see the actual properties versus expected properties of your different resources, like our instance, volume, and volume attachment. If there was any modifications, it does highlight where the modification is. So it'll show you the actual property, like source details, defined tags, whatever it is that was changed or modified. If something was deleted, it won't highlight it for you, but it will tell you like something was deleted essentially. So this is a great way to kind of detect drift and see if there's been any changes made to your stack since you last applied it. All right. I think that was everything from me that I wanted to show you guys for Resource Manager and Infrastructure as Code and Provisioning.
And what you can see into your infrastructure. All right, so we'll go over Oracle's observability and management platform, or we call it O&M for short. And so here you can have access to management and performance insights for any technology deployed anywhere. You can see it's made up of both management services and platform services. But this platform does have a few unique key features, so I wanted to talk about them. So first is that you get access to an integrated platform for all telemetry that includes metrics, logs, and traces, and it enables seamless traversal and analysis across all software components and different types of data as well. You get a cross-tier view of your application, your database, and your infrastructure performance, and you get access to cloud native and traditional technology stack support. You also get a statewide visibility across Oracle Cloud, third-party clouds, and also on-premises. And there is an ecosystem interoperability through standards-based data exchange and collection. Lastly, you have built-in intelligence using applied machine learning, and it will deliver insights without requiring any data scientists to get involved. All right, next I want to move on to our monitoring service in OCI. So the monitoring service is enabled for you to perform active and passive monitoring of your cloud resources using metric and alarm features. So your Oracle Cloud resources and services such as compute, autonomous database, and etc. They will all continuously emit metrics to the monitoring service for active monitoring. And then for your alarms, they use those metrics for passive monitoring. Alarms will have a trigger action and notification method. So the alarm trigger gets triggered when the metrics breach alarm thresholds that you set. And at the time, of a breach, then a notification will be invoked. Speaking of notifications, next we will talk about the notification service. So this service can be integrated with OCI monitoring, as we discussed in the previous slide, so that it can send notifications to different notification channels. So different channels available to you are email, HTTPS endpoint, Slack, or PagerDuty. And PagerDuty is a SaaS-based incident response platform for IT departments. And if you aren't familiar with Slack, it is a cloud-based team collaboration software. In this service, you will also create topics, and these topics will contain subscribers or recipients of the notification. Sometimes there are situations where a subscriber's endpoint does not acknowledge receipt of the message. And so when that happens, the notification service will retry delivery. And this can happen if, the endpoint is offline. So for example, for the email notification channel, maybe the email server for an email address, it could be down, and that could be causing the endpoint being offline. Next, we will talk about the event service. So inside the event service, you will need to understand three core concepts. So those would be events, rules, and also actions. So we'll go through each of these listed here. So an event represents a change in an OCI cloud resource. It could be both or either initiated by the OCI system or by user action. And events are discrete, versioned, and stateless, and they typically require a near real-time programmatic response. An event is emitted anytime a resource within a compartment is created, its attributes modified, or if its state is changed. Events are also emitted when a control plane needs to commute and communicate an upcoming change. So for example, maybe like an upcoming live migration, or when a long-lived task is complete, or when a database backup is completed. So those are all examples of that. And events are represented in OCI as a well-formatted message that defines what the event is, where it originates from, and also other metadata that customers need to take purposeful action on it. Next, we have event rules. So an event rule is a customer-defined filter on one or more field values within an event. So based on that rule matching, customer-defined actions will be invoked. Rules can have one or more actions defined to execute when they are triggered, and we'll talk about that and also show you in the console in just a little bit. But these rules will filter all incoming events, and based on the rule definition that you set, it will decide what actions to take on that event. And lastly, we have event actions. So an event action is going to be triggered by an event rule match. So there is a defined set of actions that you as the customer can choose from to execute. And then the content of that event that matches a rule is then passed to the action. So on this slide here, we have examples of what those actions could look like. One could be to invoke a function. You could trigger a notification, or you could write to stream. And speaking of functions, this is another tool that is quite powerful. And so I wanted to introduce that to you. So Oracle Functions is a tool that makes it easy for you to build cloud-native applications by letting your developers focus on writing code rather than managing infrastructure. So with Oracle Functions, you only need to write, deploy, and call your function. So there are no servers to provision, monitor, or upgrade. It's completely serverless. And I'll give you some different use cases when it comes to, when you would want to use Oracle Functions. So one example is that, maybe you want to update an autonomous database based on the trigger, such as maybe new data that is received and needs to be added to the database. Or if you want to transform files and store them in object storage, that could be another use case. If you want to extract and transform data before loading it to your autonomous database, or if you just simply want to make sure that your cloud users are complying with security policies by auditing their resources for proper security policies, or firewalls, and etc. So these are all just a couple of examples on how you could use functions. Next up, we'll be talking about the logging service. So with OCI logging, when you're running your workloads in the cloud, you will have logs generated from every point in the stack. So that includes, your infrastructure, your database, audit application, and also on premises. And the logging services just basically offer you a centralized experience to bring all of these logs into one view. Logs are natively integrated with your OCI resources for a very seamless one-click experience to turn on logs, and it gives you the ability to also manage and secure your logs to really make sure that only the authorized users have access to your sensitive data. And then within the logging service, we have 3 different types of logs. They're going to be audit, service, and custom logs. So I'll talk about each one of them real quick. So audit logs, these are logs related to events that are emitted by the OCI audit service, and these logs are available from the logging audit page, or they're also searchable on the search page. And that applies to all the rest of your logs as well. Service logs are emitted by OCI native services such as API Gateway, events, functions, load balancing, object storage, and also VCN flow logs. And each of these supported services have predefined logging categories that you can either enable or disable on your respective resources. Lastly, we have custom logs. So these are logs that contain diagnostic information from custom applications or other cloud providers or even an on-premise environment. And so these custom logs, they can be ingested through the API or by configuring the unified monitoring agent. You can configure an OCI compute instance to directly upload your custom logs through leveraging the unified monitoring agent. And then your custom logs will be supported in both a virtual machine and bare metal scenario. Next, we have our audit service, which I briefly mentioned in the previous slide. But this audit service records all API calls to resources in a customer's tenancy, as well as login activity from the graphical management console. So when you're using this service, you can achieve your own security and compliance goals by monitoring all your user activity within your tenancy. And because all console SDK and CLI calls, they do go through our APIs, all activity from those sources are going to be included. Your audit records, they can be available through an authenticated filterable query API, or they can be retrieved as batched files from OCI object storage. The audit content inside the logs include what activity occurred, who the user was that initiated it, and the date and time of their request, as well as source IP, user agent, and HTTP headers of the request. And you also have API for listing audit events. So new events are available within 15 minutes. And then 365 days of history is going to be saved by default. The retention period is going to be a tenancy level setting. So the value of the retention period setting does affect all regions and all compartments. And this retention period cannot be changed. And lastly, all API calls are searchable via the console. So we have a diagram of an architecture diagram here. And so on the left-hand side here are some of the tools that we talked about today, such as auditing, notifications, and events. And these specific services are going to be tenancy, specific. So if you have different regions that you've subscribed to and utilized, they will be applied throughout all your regions. All right, so before we conclude today's session, I do want to head into the console to show you some of the tools that we talked about today. So let me go ahead and do that. So I'm in the console now, in the home page. And since we talked about notifications and events, I do want to show you how you would pretty much get that started. So first up would be to set up your notifications. And so as we remember, the first thing you'll do is pretty much create a topic so that you can keep your subscriptions in there. So we'll go to developer services here. And then under application integration, this is where you'll find your notifications. And then to create a topic, it's a very simple process. You'll just need a name for the topic and then a description, and then you can go ahead and create it. So let's dive into this already created topic to just show you what is in here. So if you scroll down, you can see the different subscription endpoints that are part of this specific topic. So if I want to create a subscription, this is where I would do it. I can choose the protocol. So these are the different channels that we talked about: email, function, HTTPS, and etc. And let's say I go with email, then I would just input the email here. Once I hit create, OCI will send an email to this email user here, and it will just notify them that you've been added to this topic. Please confirm your subscription by clicking on this link. And then, if you ever want to edit your subscription list, you can do so by deleting and creating more. So once you have your topic set up, the next thing you would want to do is go to events so that you can set up your rules, and then make sure, you want to maybe link an action to your notification topic. So we'll go back to the menu and then go to observability and management, and we will go to event service and directly click on rules. All right, so we'll just go ahead and walk through, how to create one. So first off, give your rule a name and then a description. So what does this rule specifically do? And then here you can set the rule conditions. So basically the event will need to match the rule conditions set here in order to have the action be triggered. So there are different conditions. It's either event type or filter tag. We're going to go with event type today. And then you will need to choose the service that you want to attach to this rule. So there's a lot of services you can choose from. For today's demo, I will go with object storage, and then based on your service, you get populated event types. So for object storage, these are the ones I can choose from. If I click bucket create here, basically whenever a bucket is created, then it matches this rule condition, and then the action will be invoked. So I can also add additional event types, or if I want to add another condition, I can do that as well. You can see the rule logic on the right-hand side, and you can also view example events. So if I click on this, you can see basically this is what the notification would look like. These are all dummy information, but this is the syntax and the formatting of it. And then next would be to choose what action you want to link with your rule. So there are a couple action types. We talked about it. It's either streaming, notifications, or functions. So for today's demo, I will go with notifications to show you how we can choose that topic we were just looking at. So in order to choose a specific topic you're looking for, you'll need to select that specific compartment it lives in. So for me, that will be the shared services compartment, or shared services, yeah. And then I can click on the topic that we were just looking at previously. You can also add additional actions to this section if you would like. And basically, once I hit create rule, If a bucket is created or a bucket is updated, then it will trigger it will push a notification out to this topic and all of its subscriptions. So I won't make that right now, but I do want to show you an example of what that notification would look like. So I have a previously sent out notification from the OCIN, so I'll go ahead and share that real quick. This is an email that I got after, triggering an event, and I was part of a topic as a subscription endpoint. So you can see all the metadata. So you have your event type, which arguably could be the most important because you get to see exactly, what happened. So this notification was sent out because I created an object storage bucket. And then you get all the information associated with the action. So, where it happened, so which compartment, which resource, all the availability domain information. You get tag information as well. And you also get additional details about the bucket or the resource that was created. You can also choose to unsubscribe from this topic at the bottom here, and you would just go ahead and click on this link. So this is an example of what a notification might look like after triggering the rule match.
If there are no questions, awesome session. Thank you, Winnie and Uma. Really appreciate your time and help with this session. So yeah, our next session will be the Oracle Cloud Security Quick Start on December 3rd. So in this session, you'll be introduced to the various security features and services offered by OCI to secure your Oracle Cloud workloads. So we hope to see you all then. And then lastly, we also do have some other Day 1 and Beyond series that you can explore that are listed on this page. And thanks, everyone.